Welcome back, class. And today in topic electromagnetism, we're going to look at part 2. And in part 2, we're going to look at electromagnets. So what is an electromagnet? It's basically a magnet that is powered by electricity. So an electromagnet is a type of magnet in which the magnetic field is produced by an electric current. So we have seen before, if you have a wire with a current passing through it, this wire will produce a magnetic field like that. So the magnetic field is radially outwards from this wire. Now, what happens if you turn the wire into a coil? Sort of like this. What will the magnetic field look like? Now, the magnetic field looks like this. In fact, a solenoid, which is basically another word for a coil of wire, has the same pattern of magnetic field as a bar magnet. Okay, so here I have a bar magnet, and showing here is the magnetic field pattern of the bar magnet. And then I'm going to switch to here. I have a battery attached to a coil of wire. Okay, and now at the moment the current is off, but as soon as I turn it on, you will see that it produces the same shape or same pattern of magnetic field as a bar magnet. So it has that pattern here. The electromagnet also has the same pattern. Now, another special thing about electromagnets is that you can increase the strength of the magnetic field. If you increase the voltage, or in other words, you increase the flow of current, then you will see that the magnetic field becomes stronger. If it's zero, if there's no current, there's no magnetic field. But the more current there is flowing in the solenoid, the stronger the magnetic field. You can also reverse the magnetic field. If the flow of current is reversed, now you can see the direction of the magnetic field is also reversed. Okay, so you can do a lot of things with an electromagnet. By controlling the current inside the electromagnet, you can basically control the magnetic field, its strength, and also its direction. So you can have an electromagnet that alternates between going forwards and backwards, and you have an electromagnet that has a magnetic field that switches north to south, south to north every single time. And there are a lot of useful application for that, which we will talk about in the later chapters. Okay, so how can you make the electromagnet stronger? As you can see, if you increase the current, you can increase the strength of the magnetic field produced by the electromagnet. You can also increase the strength of the magnetic field of the electromagnet by adding in more turns. A solenoid with 10,000 turns is much more stronger than a solenoid with 4 turns. You can also add iron, just like in this picture here. You add iron in the middle of the solenoid to make the magnetic field stronger. Now that you know what an electromagnet is, let's talk about what are the applications or what are the uses of electromagnets in real life. First is electromagnetic lifts. This machine here you always see in scrap yards, and it's actually a very strong electromagnet, and it's used to lift up scrap metals. And then, if you remember from our previous video lessons, circuit breakers also use electromagnets in order for it to function. So if you remember what is a circuit breaker cuts off current if there is too much current passing through the circuit breaker. So if there's a lot of current, it's dangerous. The circuit breaker will trip or it will cut off the current, and the current won't go to the rest of the circuit or the rest of the house, and everything will be safe. Nothing is damaged. Now, how does a circuit breaker work? Nowadays, there are a lot of different kinds of circuit breakers, but I'm just going to explain to you the simplest type of circuit breaker, which is a spring-loaded circuit breaker. Here's a simplified diagram of what a circuit breaker looks like. You have the power supply here. You have a solenoid here, or in other words, an electromagnet. Here you have a spring-loaded soft iron bolt, and then here you have a spring-loaded push switch. When you turn this on, okay, let's say this is the positive terminal and this is the negative terminal. And let's say that for this particular circuit breaker, the current inside the circuit breaker is 1 amp. And for this particular circuit breaker, it can only withstand 4 amps of current. Okay, so anything more than 4 amps, this circuit breaker is going to trip, or it's going to cut off, or it's going to break. Okay, so let's say at the moment we have a safe amount of current, which is 1 amps. What does that look like? So the current will flow like that to the electromagnet. and then going through here, going through this part of the push switch, and then into the light bulb, all the rest of the circuit. Now, let's say the current suddenly from 1 amp increases to 5 amps. Okay, and that's too much and that's too dangerous for the circuit to handle. What's going to happen? So the flow of the current is still the same. They still follow the same pathway. But here, if you remember, if the current increases, the stronger the current, the magnetic field strength will also increase. So actually here, this is actually an electromagnet. When the current is small, for example, in the beginning, 1 amp, the current is small, the magnetic field or the magnetism of the electromagnet is not strong. But if there's too much current, that means the magnetic fields become strong. And then what it's able to do, it's able to attract this spring-loaded soft iron bolt. Okay, so the spring-loaded soft iron bolt will then be attracted to this electromagnet because this electromagnet is basically it's a magnet. Now, what's that's going to happen? You can see something like this. So the spring iron bolt is now attracted, and then the push switch will go up because of a spring action, and you will see the current is now disconnected. Okay, so that's basically how it works. So everything I explained is written down here. You can copy it down to your notes. The next application of electromagnets are in moving coil speakers. A good example of this is the loudspeaker. You know the loudspeaker vibrates very quickly in order to produce sound waves. So basically, the question is, how does the loudspeaker vibrate? Or in other words, how does the loudspeaker, especially the cone, move forwards and backwards? And the answer to that is it's because of these two magnets here. You have this magnet here, which is a very funny looking shaped magnet, and you also have an electromagnet in the middle. So it kind of looks like this. So you have a permanent magnet, and here is the cone of the loudspeaker. So it should be attached to a cone like that. Okay, but it's not shown here. And here you have an electromagnet. So what's going to happen is that the current passing through the electromagnet keeps alternating and changing direction. In other words, it's going forwards and backwards. What that's going to do to the electromagnet is that the electromagnet will keep reversing its poles. Okay, maybe 1 second it's south to north like that, and then the other second it becomes north to south, and then it changes again, south to north. Okay, because the poles of the electromagnet keeps changing, that's gonna interact with the other magnet, and depending on the pole, it will repel or it will attract. So basically, this forwards and backwards movement is just a movement of repelling and attraction. And that's why it's able to move forwards and backwards. It's just repelling and attracting. So it's explained here. Alternating current always changes the direction of the electromagnet. This makes the poles of the solenoid change all the time. If the pole of the solenoid is opposite to that of the permanent magnet in the speaker, the solenoid will move away from the magnet and vice versa. A series of attraction and repulsion will make the speaker to vibrate and emit sound waves. And finally, the fourth application of electromagnets in real life is the electromagnetic relay. So an electromagnetic relay is basically like a remote switch. Where do you use it? A circuit may use a lot of current, such as an air conditioner. The large amount of current is a danger to us since current can cause burns. To reduce the dangers of being electrocuted and burns, we can use electromagnetic relays. So we use electromagnetic relays for high-powered appliances. Sometimes being in direct contact with the high-powered appliances can be dangerous. Let's say you switch it on, there's suddenly a large amount of current. Now, because you're touching the switch, you're touching the appliance, that current can get into your body, and then you can get electrocuted and you can get hurt. A safer way of doing that is to have a second circuit to turn on the other circuit. So that's what a relay is. So a relay is a switch worked by an electromagnet. You use one circuit to safely control another circuit. Let's say here, in this example here, you have the output circuit, the air conditioner in this case, for example. So this is the aircon, and it's a high-powered appliance, and there's a lot of current flowing through it once it's turned on. So it can be very dangerous if you are in direct contact with it. A relay circuit is basically a second circuit that is being used to turn on the other circuit. Okay, so this is the input circuit, this is the relay circuit, it's low current. and it's safe to operate. So what's happening is that when you turn on, so you switch it, you close the switch for the input circuit, you turn it on, current's going to flow, and you see there's a solenoid here. When there's a current in the solenoid, it becomes an electromagnet. When the electromagnet is turned on, it produces a magnetic field. It then, you will see here, there's a switch that is made out of iron. And because it's made out of iron, once this solenoid becomes an electromagnet, it can attract the iron and causes the iron to close. Once the iron is closed, it then switches on the second circuit. Okay, so that's how you use one circuit to switch on the other circuit. So it sort of works like a remote control or a remote switch. So here's another example of an electromagnetic relay. So how does this work? I know it looks complicated, but let me break it down to you. So this one here, this is your input circuit. Okay, in other words, this is your relay circuit. And then this whole thing here, this other part here, this is your main circuit or the secondary circuit. This basically the circuit that is connected to the higher power appliance. Let's say an aircon. So it goes to an aircon here somewhere, another circuit here somewhere. Okay, that's not going to be shown. Let's focus on the first circuit, which is the relay circuit or the input circuit. So if you close the switch, you turn it on, what's going to happen? Current's going to flow. And then there is current inside the solenoid. The solenoid now becomes an electromagnet. So the solenoid becomes magnetized. Once the solenoid is magnetized, what's going to happen? You have this L-shaped armature. This is made out of iron. And if you have an iron and a magnet, it will be attracted. So this side will be attracted to the solenoid like that. And then because this is L-shaped, this side will be pushed up. So it's sort of like that, okay? So because the downside is being pushed towards the solenoid, the upper side will be pushed up. Now because it's pushed up, you see here, there's a gap within the contacts. When there is a gap, that means the circuit is not connected, the switch is open. But if this is being pushed up, the gap now touches each other. So when that happens, current begins to flow in the second circuit. So current is allowed to flow in the second circuit. Okay, and the circuit is turned on. So basically, this is how this works. Let me read the slide here. When switch 1 is closed, solenoid becomes magnetized. The L-shaped armature pulled towards the soft iron core, raising the top end of the armature, thus closing the contacts, and then the second circuit is complete or turned on. So, to summarize, what do you need to know or what do you need to take away for part 2 of this chapter? Make sure you know what an electromagnet is and what a solenoid is. But sometimes they call it electromagnet, sometimes they call it solenoid, but usually these two are the same thing. And make sure you are able to draw the magnetic field of a solenoid or of an electromagnet. And then make sure you know how to make the electromagnet stronger, how to increase its magnetic field. Number 1, increasing the current. Number 2, increasing the number of turns of the solenoid. And number 3, you add an iron core. And then make sure you are able to state where the electromagnets is being used in real life. So number 1, electromagnetic lift. Number 2, in circuit breakers. Number 3, in loudspeakers. And number 4, in electromagnetic relay. Also very important for you to be able to explain how an electromagnetic relay works. So basically this whole thing here. And that's pretty much it for part 2. In part 3, we're going to talk about the force on a current carrying conductor.